here are some tips for when you're going through the reactions for things you should look for. So the first thing, if I give you an actual chemical reaction and I say, tell me what's going on with this particular thing. The first thing you want to start with is, do I have elements or compounds? How many of each do I have? So here I have a copper alone, that's an element. If you have a diatomic, that's still an element. And then I have a compound here. Okay. So element and compound is going to be a single replacement reaction. Now the other things you want to look for are, do I have salts? Okay, so do I have an ionic compound? Ionic compound, you'll have either a metal and a non-metal, or you'll have a polyatomic ion in place of them with that type of charge. So if I have ammonium here, and then some kind of anion, so a non-metal ion or a polyatomic ion, that's going to be a salt. Okay? So let's go through the different types of reactions. So for synthesis, for this class, there are three kinds. One is if you have an element plus an element, that's going to make typically a salt compound. And of course, you could have two nonmetals, which would make something else like water from hydrogen and oxygen. But most of the time, if I have lithium plus bromine, I'm going to make lithium bromide the salt. You would do your charge balancing on the other side. The second type of synthesis is if I have water, then that should set up an alarm to look for synthesis, and especially if I have something with oxygen. So magnesium oxide, sodium oxide, sulfur dioxide, any of those are going to be a synthesis reaction. And that we're going to form either an acid or a base. Okay, so acids we're going to form H something, and base we're going to form something OH. Okay. Now the third type of synthesis reaction would involve the opposite of a decomposition. Okay, so if you take carbon dioxide and you add it to a metal oxide, that's going to be the opposite of our decomp. Okay, decomposition is probably the easiest one to recognize because it's only one thing. And there's nothing else where there's only one thing. So if you start with, boom, just a compound, and then that's the reaction, that's going to be decomposition. Sometimes that's tricky because sometimes it'll say you heat a compound, and the implication is you're heating it with oxygen gas. So usually if it's an actual compound you're heating, you're looking at decomposition. If you're heating magnesium metal, then you're probably looking at a combustion or synthesis reaction. So for decomp, we have a whole set of rules. If you have something that's a carbonate, so like magnesium carbonate, that's going to turn into CO2 gas and the metal oxide. If you have a chlorate, that's going to become oxygen gas and the metal chloride. If you have a hydroxide, that's going to become steam and the metal oxide. And then if you just have something with just two elements, so I have something like lithium, bromide, I think we did that earlier. But if you have something just two elements, then you're going to form the two elements. Watch for diatomics. Okay, so Br2. Okay, so for the first three, you're making some gas that you should recognize. Everyone should know CO2, everyone should know O2, and everyone should know steam. And so that's kind of the key for when you have a weird polyatomic ion-filled compound. What gas can I pull out of that? Okay, so that's what you want to look for decomposition. Now if I run one of these in reverse, and I take magnesium oxide and CO2, I would do a synthesis reaction, which is what we were talking about here. Alright, for single replacement, you're going to be looking at an element and a compound. If the element is a halogen, you're going to do a halogen displacement. And if the compound is an acid, it has H something, you're going to do a metal displacing the hydrogen. Okay, but any element and compound will be single replacement with the exception of a couple synthesis reactions that you're probably not going to see. Okay? Double replacement is almost always going to be a salt plus a salt. Now you might call these ionic compounds, I call them salts. But if you have a metal, non-metal, or polyatomic ions, plus a metal, non-metal, or something ammonium carbonate, that's going to be a salt plus a salt, and that's going to be a double replacement. So the first thing you need to be able to do for these types of reactions is identify what do you have and how much do you have. Okay, if you have two compounds, probably looking at double replacement. The exception would be this. If you have an element in a compound, probably looking at single replacement with exceptions that are probably not going to come up in an introductory chemistry class. If you have one thing, that's definitely decomposition. If you have two elements, definitely going to be synthesis. Okay? The last kind is combustion. And combustion is probably the easiest for us to recognize because we like to light things on fire. There you're going to have C something, H something, maybe an oxygen attached, plus O2. You're going to burn it. So if you're burning something, and that's a really easy one because that will always make CO2 in water. Okay, so for identifying which type you have to be able to look at what you're kind of starting with. Okay, so if we go through and we now look at some various types of reactions, let's go ahead and look at something we can make up. So if I say calcium plus water, okay? Calcium plus water, I would start by saying, here I have an element, here I have a compound. Ding, 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 that bell goes off, and I say, okay, that's probably single replacement. Okay? So then, I would have to go to an activity series and see if this reaction occurs by looking to see if my element is further to the left. Okay, in this case, calcium is at the point where it will react with water, and I would displace this. Now, active metal plus water, I would end up making the base calcium hydroxide, hydrogen gas. Okay? If I do a different reaction and I say LiCl plus AgNO3, well, now I say I have a compound, two elements. I have a compound, two elements. Lithium's a metal, chloride's a non-metal, that's a salt. Silver's a metal, nitrate's a polyatomic ion, also a salt. Now I'm looking at double replacement. So single replacement here, double replacement here. Now I know I'm going to switch to lithium and silver and rebalance my charges to make formulas. Now for this, that's easy because everything in here is charge of 1. So I'll actually keep my subscripts consistent in this particular one, and I'll end up with this. Okay. Now for single replacement and double replacement, you always assume those are taking place in water. So when we get into states of matter, then you're going to go through and say, okay, lithium chloride in water, is it soluble or not? So for salts in water, they're always going to be either aqueous or solid. This is soluble in water, it would be aqueous. This is insoluble in water, so it doesn't dissolve, therefore it would be solid. This one would be soluble in water, it would be aqueous. So this would be my precipitate in that case. Okay, this again, I assume this is in water, especially since I added it to water. And so therefore I would go through and say, okay, is that soluble in water? If it is, I would put aqueous. If not, I would put solid. Okay. One of the trickiest ones that I find is when we take something like water and we add it to, let's say, SO2. So water and SO2, so I have oxygen plus water, that's synthesis. So this a lot of people will take this for a double replacement because it's two compounds. But that's the one exception to that rule. So for this, I'm going to make an acid. Okay, when you make your acids, usually it's best to try and see if you can just literally add the things together. And if you make a polyatomic ion, you recognize. This one I can't, and that works, that's great. If it ends up looking weird, try looking up polyatomic ions and see which one will balance really easily as an acid, and that will be what you make. Okay, so for synthesis, I don't assume I'm in water, but I am adding something to water. I'm adding a gas to water, so liquid, gas, and then this would then be aqueous. Your acids will usually be aqueous. Okay. Then, if I pick something like calcium carbonate and I heat it, that's only one thing, that's going to be a decomposition. So I have solid calcium carbonate. I'm going to make a gas I recognize, and CO2 should jump out at you as being very similar to that carbonate. That's your gas. And then you're going to make the metal oxide. Calcium is a +2, oxygen is a -2, so I just need a big CaO, and that would be a salt, so therefore that would be solid. So that's how you want to go about and attack these, is you want to start by, I have one compound, I have two compounds, I have two compounds, they're both salts, I have an element and a compound. That's the analysis that's going to set up what do you do. Now at that point you have a lot of other things to do, but that first step is really critical to being able to kind of come in and figure out the rest of the problem. Okay? So whether you have elements or compounds will kind of set up your recognition to what type of reaction this is, and as you practice it you'll start to get the hang of the things that are kind of exceptions to those, and you'll start to pick up on when you have single replacement or double replacement